Hi everybody, today we are looking at similar right triangles, and you can see here we got a couple different things that we're trying to do. We want to be able to use the properties of altitudes within triangles to identify similar right triangles, and then eventually we'll use properties of those similar right triangles to solve applications. Okay, so if you look at the next page in our notes, we've got this triangle, this larger triangle, but we've got an altitude running right down the middle of that triangle here. And because of that altitude running down the middle, it splits it into two other triangles. So a small one here, what I'd call a medium one here, and then we've still got the large one all together. So it's really three different triangles that we're talking about. And the question to the right says, are all those three triangles similar, and how would you know? Well, I'm going to bring in those three triangles, but I'm going to show them to you separately. So here are those three triangles in order of size. So the large one, and then the medium and small ones that make up the large one. And you'll notice I rotated them all so that they're in the same alignment, so you can compare these a little bit better. Are all three triangles similar? Well, we said that there's really three different ways to prove the triangles are similar. Either by angle-angle, or by side-side-side, or by side-angle-side. Those were the different similarity postulates that we looked at. Well, I don't really know anything about any of the sides in terms of comparison. I guess you could say that this side is the long side of the small triangle, and it's going to be congruent with itself, so the short side of this medium triangle, but that's about the only thing that we really know in terms of sides. So that tells me I'm not going to be using the side angle side, and I'm not going to be using the side postulates. I'm going to be looking at angles that are the same in all of these. Okay, so that's what we're going to do now, and hopefully we've got enough to use the angle-angle theorem. Okay, so if I look at angle B here, that's going to be the same. That's angle B in this large triangle. It's also angle B in the small triangle. So those two I can say are the same. If I look at, let's say, angle A in the large triangle here is the same as angle A in the medium triangle. If I look at angle, let's call it, it's going to be angle D here in the small triangle. Because that's a right angle, we can also, and it forms 180 degrees, we could say that angle D in the medium triangle over here is also going to be the same as well. And then if you look back up at the diagram, you'll see that in the large triangle up at the top, angle C is also a right triangle. So we can mark that as well. Now that gives us a couple different things that we can compare. If you're looking at this larger triangle, saying, well, that's got one of the same angles there and a second angle there. By the angle-angle similarity postulate, we can say that those two triangles are similar. And we're going to be able to say the same thing between the larger triangle and the smaller triangle, because again, we've got one pair of angles that are the same, the 90-degree angles, and then a second pair of angles that are the same. Okay, so the large triangle is similar to the medium one, the large triangle is similar to the small one, and so therefore the medium and small one must all be similar. All three of those are similar triangles because of that angle-angle similarity postulate. And that's what we see here in Theorem 7.5 as well, and you should have these in your notes. It's saying if we've got this triangle, a right triangle, that has an altitude split down the middle of it, which splits it into two smaller triangles, one over here, the smallest one, and then a medium size here, it's always going to form a total of three triangles, all of which are similar. And that's kind of the basis for where we are going with all of this. Knowing that I've got three similar triangles, it's going to allow me to set up different proportions and find different lengths based on certain given information. So let's look at the next part of our notes. Here I've got this larger triangle that's again got this red altitude splitting it into two smaller triangles as well. And what I want to show you is that all three triangles have proportions that we know are going to be equal to one another, ratios that are going to be equal to one another because we know the triangles are similar. So let's take a look. Out of these three triangles, I'm just going to pick two of them. Let's pick the medium triangle. I'll put this as the medium over here. That'll always be our numerator. And then we'll compare that to the small triangle. Small triangle will always be in the denominator. And then I've really got three parts of every triangle that I could compare with one another. We've got a short leg, we've got a long leg, and then we've got the hypotenuse. Okay, and I'm really going to encourage that you always set up your proportions this way, where you're labeling what's going to go in the numerator, what's going to go in the denominator, and what's going to go on each one of those ratios, because then it's just a matter of identifying the triangle and filling in what you have there. So if I'm looking at this section right here, I'm looking at the medium triangle, which is this guy, and I'm looking for the short leg within that medium triangle, which is really, in this case, the red segment. I don't have it labeled as anything. I don't have a length. So as of right now, I'm just going to call it the red. If I look at the small triangle, and I've got down here the small triangle, short leg, that would be orange. Okay, so whatever that the length of the red line compared to the length of the orange line, that's the ratio that I would want in this fraction. Let's go to the next one. If I look at the medium triangle and look at the long leg, that's going to be the blue length, or the blue side. If I look at the small triangle and the long leg of that small triangle, that is the red segment. Okay, so that red segment is the small triangle's long leg, which we're seeing here. It's also the medium triangle's short leg, which we're seeing here. And that's okay to have it in a couple different spots. It's the same line segment, just used differently in different triangles. Okay, then I go to the last one. If I'm looking for the medium triangle's hypotenuse, that is going to be the black line segment. And you can compare that to the small triangle's hypotenuse, which is the green line segment. Okay, so all three of these ratios are going to be equal. And again, I don't have any values in here for you yet, because I just want you to see how this goes together. Let's do the same kind of thing over here in this next triangle on the right. Again, a large right triangle that's been split with an altitude. And we're going to set up the labels for our ratios. Let's compare the small triangle. We'll put a little triangle symbol there. That'll be the numerator, and we're going to compare that to the large triangles in the denominator. And again, we'll have those three sides. It doesn't matter which order you put them. Before I start with the short leg here, I'll start with the hypotenuse. We'll do short leg here, and then we'll do the long leg in our final ratio. Okay, so as I do that, I'm going to find the hypotenuse of the small triangle first. Well, here's the small triangle down here, and I want the hypotenuse of that small triangle, which is going to be XR. Okay, so we're being a little bit more specific than we had been in the past. Okay, right below that, looking at the large triangle, and its hypotenuse is going to be XZ. Okay, so that's going to give us our first ratio. Looking at the other ones, the short leg of the small triangle is going to be XY. And then looking at the large triangle, its short leg is going to be XR. Okay, so just these two alone form a proportion of two equal ratios. But we could do another ratio here. Looking at the small triangle's long leg, that would be YR. That would be this guy. And compare that to the large triangle's long leg, that would be ZR. That would be this one. Okay, so there again you have these three different ratios. You can use any two of them to set up a proportion. I would suggest that you try the next section of your notes on your own, or if you don't have the notes with you, use a scratch piece of paper to fill out those ratios to set up equal proportions based on the given line segments with the altitudes cutting through these right triangles. If you've filled these out, you might have ratios that look something like this. Okay, now don't freak out if you got something a little bit different, because what I did in this first one on the left, just dealing with the colors, I decided to have my small triangle and my medium triangle be the ones that are being compared. Maybe you compared small to large, or maybe you compared large to medium, or whatever it was. And you could have either one in the numerator and either one in the denominator. I did short leg, then long leg, then hypotenuse, but again, you could switch those around. Okay, the same thing goes for the triangle on the right. Those could be switched really in any order as long as you consistently have the same thing in your numerator, consistently the same thing in your denominator, and consistently the same things in each of your columns or each of your ratios. Okay, but this is an example of proportions that you could set up. Yours might have looked a little bit different.